Dear students, welcome to the video Continuous Random Variables. In statistics 1, we learned how to use normal distribution properties in order to deal with some continuous random variables, like the speed of cars passing through a specific point, height, age, length. These are some of the examples of continuous random variables. Now, in order to deal with variables which are continuous, we need to have their PDF, which is abbreviation of probability density function. Probability density function. Now, so what are properties of PDF, probability density function? First, we know that for any event in your sample space, probability is taking values more or equal to 0 and less than 1. So f of x, given that f of x is a probability density function, then f of x should be greater or equal to 0. Now, second property, we know that sum of all outcomes in the sample space add up to 1. But here we are dealing with continuous normal and random variables. So instead of sum, actually we use integration. So integration negative infinity to positive infinity, f of x d of x should be equal to 1. So it means that sum of all events in the sample space should add up to 1. Now, for the variables which are not defined in your sample space, f of x will be considered as 0. So if x is not an event in your sample space, f of x will be 0. Now, in order to calculate probabilities, we are supposed to consider the following points. First, for each individual value in your sample space, f of x or probability of x will be 0. So f of x, probability of x is equal to, for example, a will be 0. So for one individual value, a is actually one value in your sample space, so probability will be 0. It is the first point. The second point, as we cannot actually find the probability for individual points, so we have this probability in order to calculate probability. So probability of x between a and b is equal to probability of x more or equal to a less than b. So here a is included, or more than a less or equal to b, or both are included. So all these statements will give you the same probability. So no matter a, upper bound and lower bound are of the interval are included or excluded. So you are supposed to consider these points calculating probabilities. The third one, which is really important, in order to find probability of a continuous variable in the interval, for example, x between a and b, so probability of x between a and b, I just told you that no matter a and b are included or excluded. So it will be integration of a to b, f of x d of x, where f of x is your PDF, probability density function. Look at the first example. The height reached by water erupting from a broken water pipe, x meters, is modeled by the following PDF. f of x is x squared over k, x is between 1 and 10, otherwise 0. Part A show that k is equal to 333. B, sketch the graph of f of x. And part C, find the probability that the water reaches a height of at least 6 meters. To answer the first part, we know that as this function is a PDF, so integration of upper lower bound of your interval is 1 and 10, so x squared over k and d of x should be 1. Now, so I can factor 1 over k, integration of 1 to 10 x squared, d of x should be 1. So 1 over k, integration of x squared will be x cubed over 3 from 1 to 10 should be 1. So I first replace 10, it should be 10 to the power of 3, which is 1000 over 3 minus 1 over 3 should be 1. So 1 over k times 1000 minus 1, it will be 999 divided by 3 should be 1. If you simplify, it will both divisible by 3, it will be 333. So it will be 333 over k is 1. So k will be 333 as the answer for the first part. Part B, sketch the graph. So f of x, I write it as we found k, so it is x squared over 333, x between 1 and 10, otherwise 0. So it's a quadratic function bending upwards. So x here, f of x, let me change the color. So if x is 0, it will be 0, sorry, from 1 to 10. So if x is 1, so it will be here 1, here example 10, 1. If x is 1, it will be 1 over f of x is 1 over 333. So a small values near to x-axis, so it is 1 over 333. And if x is 10, so f of x will be 100 over 333, here 100 over 333, so it will be here. And we know that it bends upwards, so we will have such a graph. Part C, find the probability that water reaches a height of at least 6 meters. See, at least 6 meters means 6 or more. So we are supposed to find the probability of here x is actually the height in meters, so at least 6 is means 6 and more. So we are supposed to find probability of 6 to 10, because outside this range will be 0, so we just need to find the probability of this PDF from 6 to 10. So it will be integration of 6 to 10 x squared over 333 d of x. So if you integrate, it will be x cubed over cube. Integration of x squared will be x squared over 3, then 3 is multiplied by 333, it will be 999. So from 6 to 10, once we replace upper bound, 10 cubed over 999 minus 6 cubed over 999, which is equal to 1000 over 999 minus 6 cubed, which is 216 over 999, and giving you an answer of 784 over 999. It is a probability that the water reaches a height of at least 6 meters, means 6 or more. Second example, it says a brand of laptop battery has a lifetime of X years. It suggested that the variable X can be modeled by the following PDF. F of X is equal to 2 over X squared for X greater or equal to 2, otherwise zeros. Part A, sketch the graph of F of X. Part B, show that F of X has a properties required of a probability density function. Part C, find the probability that the battery lasts for more than 3 years. And part D, work out the value of the value m such that probability of x less than m is half. So for the first part, get x f of x. If as you see, x is defined for the values greater or equal to 2. So if x is equal to 2, so it will be 2 over 2 squared, which is 1 over 2. So for 2, it will be half. So it will be here. And if x greater than 2 tends to infinity, then f of x will tend to, because 2 over infinity will be 0. So it will, x-axis will be horizontal asymptote. And if you take the second derivative, we will see that this function will bend upwards. So you will have such a function. Let me construct another more smooth, such a curve. For the second part, it says show that f of x has properties required of a probability density function. So you clearly see that all the the values f of x take in this interval are greater or equal to 0. The 2 over x squared will always give you non-negative numbers. So the second property that required to be checked is probability of negative infinity to positive infinity. But here in this function is defined for the numbers greater or equal to 2. So integration of 2 to infinity 2 over x squared d of x, we should check whether it is 1 or not. So I write 2 and infinity, so I write 2 to the power 2x to the power of negative 2 d of x. It will be if you integrate, it will be 2 to the power of 2x to the power of negative 2 plus 1 over negative 1. So it will be 2x to the power of negative 1 over negative 1. So it will be negative 2 over x after integrating from 2 to infinity. Now if we put infinity, it will be negative 2 over infinity minus, now put lower bound, which is negative 2 over 2. So negative 2 over infinity will be 0, negative negative positive 1, so it is 1. So the second property also satisfies here. Part C, you are supposed to find property of that the battery lasts for more than 3 years. So integration of 3 to infinity 2 over x squared d of x must be calculated. So the probability of 2 over x squared is negative 2 over x from 3 to infinity. So it will be negative 2 over infinity minus 2 over 3, giving you an answer of positive 2 over 3 as the answer for the third part. For the last part, work out the value of m such that probability of x less than m is equal to half. This part is actually indirectly teaching you how to find the median, because median is located in the middle of data. So the probability of events before the median is half, after the median is half. So m is actually median. In the following parts, you will completely learn how to find quartiles and median. So now let's do this example. Probability of x less than m. So it means that probability of 2 to m 2 over x squared d of x. So probability of 2 over x squared is negative 2 to x, lower bound 2, upper bound, sorry, m. So it will be negative 2 over m minus negative 2 over 2. So it will be negative 2 over m plus 1. And this probability is to be half. So if you take common denominator, it will be minus 2 plus m over m is equal to 1 over 2. If you do cross multiplication, minus 4 plus 2m is equal to m. I transfer this m to the left hand side, it will become 2m minus m, which is m, is equal to 4. This part is over. Thanks for watching this video.